Hey guys, in this tutorial we are going to see the chapter Exponents. This tutorial may go long because in this tutorial we are going to finish all the chapter Exponents, right? So let us begin with laws of exponents. So very first law you can see over here is the product law. Product law is a raised to m into a raised to n equal to a raised to m plus 1. Let me give you one example of it. See, 5 raised to 2 into 5 raised to 3, then we can write it as 5 raised to 2 plus 3 and it will be 5 raised to 5, and then we can further solve it. But here the thing I wanted to tell you that if base are same in the multiplication, then simply we can add the powers of it, right? So here the answer will be 5 raised to 5, right? So that is what the product law of exponents. Let's go and see second law. The second law is quotient law. Here you can see quotient law is a raised to m upon a raised to n will be equal to a raised to m minus n if m is greater than n. Let's take 10 raised to 5 divided by 10 raised to 3 is suppose the given thing, and what it will be equal to? It will be equal to 10 raised to 5 minus 3, right? And this will be applicable when m is greater than n, nothing but this 5 is greater than this 3. And what will happen if the power of the denominator is greater than the power of numerator? In this case we can write, suppose this is the case, then we can write it as 1 upon 10 raised to 5 minus 3. This is the quotient law of the exponents. Let me tell you power law of exponent. Power law of exponent is if 10 raised to 5 is the one thing and suppose whole thing is having some power, suppose 3 is the power of the whole this 10 raised to 5, then we can simply write 10 raised to 5 into 3 and it will be equal to 10 raised to 15. So this is about the power law of exponents. So all these are guys the laws of exponents, and these are very crucial to solve the examples coming ahead, right? So let me take you to another thing. Here are the two notes you need to keep in mind always. If minus 2 raised to n is the given thing, and if this n is even number, then it is equal to 2 raised to n only. And if in this case minus 2 raised to n, this n is the odd number, then it will be equal to minus this 2 raised to n. Okay, so it is totally depend on the power. If it is even number, then this will be the result, and if this is the odd number, then this will be the result. And this will be applicable for all the possible cases in actual practice, right? So these are the generalized case of it. Okay, so minus a we have taken instead of minus 2, and it will be equal to a raised to n if this n is even, and minus a raised to n will be minus this a raised to n if this n is odd number, right? Let me give you example for it. Suppose here is the number minus 10, and if we have to take minus 10 raised to 2, then it will be simply equal to 10 raised to 2 because this 2 is the even number, and it will be equal to 10 to the power 2, nothing but 100. And suppose minus 10 raised to 3, here 3 is the odd number, and it will be equal to minus 10 raised to 3, and it will be equal to minus 1000. Let me tell you another note. If suppose a is the number given and minus n is the power of it, then it will be equal to 1 upon a raised to n. Or if there is another condition, if there is number given a and n is the power of that number, then it will be equal to 1 upon a raised to minus n. Nothing but we can simply say a raised to n and a raised to n are reciprocal of each other. It means what? 10 raised to the power minus 5 will be equal to 1 upon 10 raised to 5, or 15 raised to 5 will be equal to 1 upon 15 raised to minus 5. So that is what the example of this note. Let us go for solving actual examples. Here is the first example we have. 5 raised to 2 minus 3 raised to 2 into 2 upon 3 raised to minus 3. Let us solve this bracket first. It will be equal to 25 because 5 square is 25 and 3 raised to 2 is 9 into 2 upon 3 raised to minus 3. It will be equal to 2 raised to minus 3 into 1 upon 3 raised to minus 3. It will be equal to 25 minus 9 is 16 into 2 raised to 3 is 1 upon 2 raised to 3 into 3 raised to 3, which is at the denominator. It will go up in the numerator and it will be equal to 3 raised to 3. So the number will be 16 into 1 upon 2 raised to 3 is 8 and here 3 raised to 3 is 27. So the number come over here is 2 into 27. 2 into 27 is 54. So 54 is our final answer. Here is the another example in front of us. In bracket 3 upon 5 and whole bracket raised to minus 2, and this we have taken into one curly bracket and that curly bracket raised to the power minus 2. Okay, how we have to solve it? We have to use power law over here. If a is the number and power of a is m and whole power is n, then we can write a raised to m into n. Simply we can apply this power law over here. So 3 upon 5 will remain in the inner bracket and this minus 2 and this minus 2 will come into multiplication. So 3 upon 5 and whole raised to minus 2 into minus 2 will be plus 4, and here 3 raised to 4 upon 5 raised to 4. 3 raised to 4 is 81 and 5 raised to 4 is 625. This will be our final answer. Here is the another example. If 9 into 3 raised to x is equal to 27 raised to 2x minus 3 is the number, is the equation given, then we have to find out value of x. Okay guys, what will be the first step? First step will be 9 into 3 raised to x will be equal to this 27 we can write as 9 into 3 as raised to 2x minus 3. So we can convert this 9 into factors. 3 into 3 into 3 raised to x. 9 I have converted into 3 into 3, and this 9 we have to convert into 3 into 3, and this 3 will remain as it is and this power will remain as it is, right? So this 3 into 3 into 3 raised to x, what it will become? It will become as 3 raised to 2 plus x, and right hand side will become 3 raised to 3 because these 3 3's are coming together to make 3 raised to 3, and here the power will remain as it is because see a raised to m into a raised to n, it will give us a raised to m plus n. This multiplication law of exponents I have used over here, right? So 3 raised to 2 plus x will remain as it is, right? And right hand side will come like 3 raised to 3 into the bracket 2x minus 3 because here is the power law, a raised to m and whole raised to n is the given thing. Suppose then we can write it as a raised to m into n. So the next step will be 3 raised to 2 plus x, and right hand side will become 3 raised to we have to multiply this whole bracket by the 3. So 3 into 2x will be 6x minus 9, right? So here you can see base is same on both the sides, and we can simply equate the powers. So what will be the equation we will get? 2 plus x equal to 6x minus 9. If we solve this equation we will get the value of x. So now what we have to do, we have to take this x on right hand side and this 9 on left hand side. So 2 plus 9, because 9 is negative over here, after coming to left hand side it will become positive, and this x is positive, after sending it to right hand side it will become negative. So 6x minus x is 5x. 5x equal to 11 and x will be 11 upon 5. So value of x is the 11 upon 5. This is what our final answer, right? Here are the more things about exponents. Here is the first thing we have in front of us. a into b raised to n will be equal to a raised to n into b raised to n. It means what? Suppose here in the bracket 5 into 2 present and whole bracket raised to 3 is the thing, then we can simply write it as 5 raised to 3 and 2 raised to 3 separately. The power is of whole this bracket, and in this bracket 5 into 2 present, and this we can expand as 5 raised to 3 into 2 raised to 3, right? Here is the another note, a upon b raised to n. Suppose here we take example 5 upon 3 raised to 2, then we can write it as 5 raised to 2 upon 3 raised to 2. Just we have separated the powers to the numerators as well as denominators, right? Here is the another thing, a raised to 0 equal to 1 if a is not equal to 0. I can give you example of it. 100 raised to 0 is equal to 1. 5 raised to 0 is also equal to 1. Means any number raised to 0 is 1, but that number should not be equal to 0. Here is the another thing, a raised to minus m equal to 1 upon a raised to m, and 1 upon a raised to minus m equal to a raised to m if a is not equal to 0. We have already seen this thing. Here is the another thing, nth root of a is equal to a raised to 1 upon n. Here I can give you one example. Suppose square root of 4 is equal to 4 raised to half, and here is the another thing, nth power of a raised to m equal to a raised to m upon n. Suppose here is the thing, cube root of 5 raised to 2 will be equal to 5 raised to 2 divided by 3, right? So this is what the example of this note, and we have to apply all these rules in the numericals coming ahead. Let's see first numerical. Here we have to compute the given thing. The given thing is 56 upon 28 raised to 0. 56 upon 28, we can write 0 separately, divided by 2 raised to 3 upon 5 raised to 3, multiplication 16 upon 25. Here which rule we have to use? BODMAS, right? According to this rule we have to solve bracket first, then after we have to do division, then we have to go for multiplication. So this division we have to do first, so we can simply write it as this. The next step would be, what will be this thing? 1 upon 1, because anything raised to 0 is 1. So 56 raised to 0 is 1, 28 raised to 0 is 1, and this divided by 2 raised to 3 is 8, and 5 raised to 3 is 125 into 16 upon 25, right? So in next step we can write this 25 will come at the numerator, 125 divided by 8, this 8 will go to the denominator, and this 16 upon 25 as it is. Now here we can reduce the numbers. 8 into 2 is 16 and 25 into 5 is 125. So only number remains 5 and 2, and 5 into 2 is 10. So 10 is the answer of this given numerical. Another numerical is 625 raised to minus 3 by 4. First of all, we have to find out factors of this 625. For finding out factors of 625, let's do division. Let us start with 5. Let's begin with 5. 625 upon 5 is 125. Again we can divide it by 5. 125 divided by 5 is 25. Again we can divide it by 5. Again we can divide it by 5, and here is the number 1. So 625 is what? 5 raised to 4 and whole raised to minus 3 by 4 present, right? So this is the first step, and in another step we can write 5 raised to 4 into minus 3 upon 4, right? So here you can see 4 into minus 3 upon 4 is the number which comes at the power of this 5. So 4 and this 4 are in division with each other, so we can just cancel them, and here is the number we get is 5 raised to 3, and we can write it as 1 upon 5 raised to 3, and 1 upon 5 raised to 3 is 125, right? So the answer of the given problem is 1 upon 125. Here is the another sum. The given sum is minus 3 raised to 4 minus 4th root of this 3 and full bracket raised to 0 into minus 2 raised to 5 divided by 64 raised to 2 by 3. Again, here you need to keep in mind Bodmer's rule, right? So minus 3 raised to 4 will be equal to 3 raised to 4 simply, because you know that power is the even number and even power of any negative number will be positive only. So 3 raised to 4 minus, this is the number present in the bracket and this bracket raised to 0, right? It means what? Anything raised to 0 is 1, so 1 will be the number here, into this minus 2 raised to 5. What does it mean? It will be equal to 2 raised to 5, because odd power of negative number will be negative always, right? So 2 raised to 5 minus 2 raised to 5 and this divided by 64 raised to 2 by 3. This is the number, and I have taken this square bracket over here because we have to do division first according to this Bodmer's rule, right? So this was the first step. Let us go for second step. 3 raised to 4 minus 1 into the square bracket. This 2 raised to 5 is 32 minus 32 divided by 64 is what? 64 is nothing but the 4 to the power 3, and here 2 upon 3, right? So let me write another step. 3 raised to 4 as it is, 1 as it is, this minus 32 as it is, divided division sign as it is, 4 raised to 3 into 2 upon 3 we can write. This is 3, and I can cancel this 3 because according to power law we can multiply the powers, right? So 3 get cancels, the number remain over here is 4 and its power 2. So I can write it as 3 raised to 4 minus 1 into the square bracket minus 32 into 1 upon 4 raised to 2, right? Because here it is at the numerator when there is division sign, and if I convert this division sign into multiplication sign, it will go to the denominator. It will be equal to 3 raised to 4 minus 1 and minus 32 into 1 upon 16, and 16 into 2 is 32, and this will become 3 raised to 4. 3 raised to 4 is 81. 81 minus 1 into this minus 2, right? So it will be equal to 81 minus plus 2, and 81 plus 2 is 83. So this is our final answer of this question, right? Let me take you to another example. Our another example is this one, 27 raised to 2 upon 3 divided by 81 upon 16 raised to minus 1 upon 4. So here we have to write a 27 as 3 raised to 3 because third power of 3 is 27, and this 2 upon 3 we can write as it is. Here is the division sign. Here 81 I can write as 3 to the power 4, and at the denominator I can write 16 as 2 to the power 4, and this whole bracket raised to minus 1 upon 4. This is our first step. In second step, what we can write? 3 raised to 3 into 2 upon 3 divided by 3 raised to 4 into minus 1 upon 4 whole divided by 2 raised to 4 into minus 1 upon 4. I have just separated the powers of numerator and denominator. So the 3 raised to 4 in raised to minus 1 upon 4 will become 3 to the power 4 into minus 1 upon 4. Denominator will become 2 to the power 4 into minus 1 upon 4. So this is what the power of 2, and this is what the power of 3. In next step I can cancel this. So the thing remain over here will be 3 raised to 2, and this divided by 3 raised to this 4 will get cancelled, -1, and 2 raised to again -1, right? So I can write as, here you can see both the numbers are having negative powers, so I can take a denominator to the numerator and a numerator to the denominator so that their power will become positive. So 2 divided by 3 I can write, and again I have to do one thing, that 3 raised to 2 into 3 upon 2, because I have changed this division sign into multiplication sign. So again denominator will come to the numerator and numerator will go to the denominator. So 3 to the power 2 is 9, 9 into 3 is 27 upon 2 is the final answer. Next example is, we have to simplify this given thing, right? The given thing is 64 raised to -2, and this is in square bracket, and this square bracket raised to -3, whole divided by, in square bracket there is one curly bracket, and again in curly bracket there is one parenthesis, -8 raised to 2, and this curly bracket raised to 3, and this square bracket raised to 2. So simply I will start with this 64. 64 is nothing but 2 to the power 6, and this -2 as it is, and this square bracket raised to -3 as it is, whole divided by -8 I can write as 2 to the power 3. It will be minus, here it is parenthesis, its power is 2, here it is in curly bracket and curly bracket to the power 3, and again it is in square bracket and square bracket raised to 2. This is the first step. Let me write second step. 2 to the power 6 into -2 into -3 I can write, because according to power law of exponents I can multiply the powers of the one number, whole divided by -2 raised to 3 into 2 into 3 into 2, right? So the next step will be 2 to the power 6 into 2 is 12, and 12 to the 12 into 3 is 36, and here minus sign will get cancelled, it will become positive, and this divided by -2 raised to 3 into 2 is 6, 6 into 6 is 36, right? So the number coming over here is 2 to the power 36 divided by -2 to the power 36. As this 36 is the even number, I can simply write 2 to the power 36, and 2 to the power 36 divided by 2 to the power 36 will come 1. So this 1 will be the answer of this given question. Another example is x raised to a upon x raised to b, whole bracket raised to 1 upon ab, and xb xc whole bracket raised to 1 upon bc, xc xa 1 upon ca is equal to 1. We have to show whole this thing as 1. So let's take our first step. What we can write, x raised to a into 1 upon ab whole divided by x raised to b into 1 upon ab into x raised to b into 1 upon bc, this divided by x raised to c into 1 upon bc into x raised to c into 1 upon ca, this divided by x raised to a into 1 upon ca, right? So here you can see this a and a will get cancelled, b and b will get cancelled, b and b, c and a will get cancelled. In next step we'll write the things remaining over there. X raised to 1 upon b is remaining, x raised to 1 upon a is remaining, into x raised to 1 upon c is remaining divided by x raised to 1 upon b is remaining, then x raised to 1 upon a is remaining, and here x raised to 1 upon c is remaining. So here you can see this x raised to 1 upon b and x raised to 1 upon b we can cancel, x raised to 1 upon a and x raised to 1 upon a we can cancel. Similarly we can cancel this x raised to 1 upon c. So nothing remains over there except 1. So this is what our left hand side, and as we can see in the given problem statement, our right hand side is also 1. Simply we can say this whole left hand side is equal to 1. So in this way we have showed left hand side is equal to 1, right? Let me take you to another example. Let's see our another example. Our example is a raised to 2n minus 3 into a raised to 2 and this bracket raised to n plus 1 divided by this a raised to 4 minus 3 equal to a raised to 3 raised to 3 divided by a raised to 6 minus 3. This is the given thing, and from that we have to find out value of n, right? So let us take our first step. A raised to twice n minus 3, we can't do anything in this. We can multiply this 2 into 2 with this n plus 1. So what it will become? Twice n plus 2. According to power law, I have multiplied this 2 with this n plus 1 and it became twice n plus 2. This whole divided by a raised to 4 into 3 will be minus 12 equal to a raised to 9 divided by, I can write it as a raised to 9 divided by a raised to 6 into 3 is 18, but sign will be minus, right? So a raised to twice n minus 3 into a raised to twice n plus 2. Here base is same, we can add powers. A raised to twice n minus 3 plus twice n plus 2, this whole divided by a raised to minus 12 will be equal to, here you can see this a raised to 9 is there, and as bases are same, we can just subtract powers. So minus 18, right? So a to the power this twice n plus twice n will become 4n, this minus 3 plus 2 will become minus 1 divided by a to the power minus 12 will be equal to a to the power 9 plus 18 will be 27. In next step, here we can write as base is same, we can just subtract the powers. A to the power 4n minus 1 minus minus 12 equal to a to the power 27. In next step, we can write a to the power 4n as it is minus 1 plus 12, so plus 11 it will be, and which is equal to a to the power 27. And in next step what we have to do, as bases are same on both the sides, we can just equate their powers. So 4n plus 1 will be equal to this 27, 4n plus 1 equal to 4n plus 11 equal to 27. So in next step this 4n will be equal to 27 minus 11, 27 minus 11 is 16. As 4n equal to 16, n will be equal to 16 upon 4, and from this we can get value of n is equal to 4. So n is equal to 4 is the final answer. Here is our next example. A to the power twice n plus 3 into a to the power twice n plus 1 into n plus 2, a to the power 3 twice n plus 1, a to the power n into the bracket twice n plus 1, right? So let's begin with our numerator. A to the power twice n plus 3 remains as it is into a to the power. Let us solve these two brackets. Let's multiply by one bracket to another bracket, so it will become twice n square plus 4n plus n plus 2. This whole divided by a to the power 3 into whole this twice n plus 1, it will become 6n plus 3. This a raised to n into whole this bracket, so twice n square plus n. In next step, we can write a to the power twice n plus 3 into, let's simplify this, a to the power twice n square as it is, plus 4n is 5n plus 2 as it is, whole divided by, here you can see in the denominator base is same, and we can simply add the powers according to multiplication rule or product rule, right? So 6n plus 3 plus twice n square plus n. So here we will do same thing in the numerator as well. So a to the power twice n plus 3 plus twice n square plus 5n plus 2, this whole divided by a to the power, we will write in the decreasing power of n, twice n square plus 6n plus n is 7n, and this 3 as it is. Next step would be a to the power twice n square first, twice n square plus 2n plus 5n is 7n plus 3 plus 2 is 5, and this divided by a to the power twice n square plus 7, here is the plus sign guys, so 7n plus 3, right? So in next step I can write here, I will write the next step. As you can see, this base is same, and these are the whole powers, so we can simply subtract the powers as they are in division. So a to the power twice n square plus 7n plus 5 minus this whole bracket twice n square plus 7n plus 3. Let me write in another step, twice n square as it is, 7n as it is, 5 also as it is, twice n square minus 7n minus 3. This twice n square will get cancelled, 7n will also get cancelled because they are having opposite signs, and this 5 minus 3 will be 2, so answer will be a raised to the power 2. So this is what our final answer. In this way guys, we have taken most possible number of examples in this tutorial. I hope guys you got whole this chapter exponents, and if you have liked this tutorial, please don't forget to subscribe this channel, and please share this tutorial with your friends also, and I will see you guys in the next one.